280 pixels. Okay, per column I have 1024 pixels. Okay, so in the next, similarly 640 cross 480 or whatever, these are the different frame size for the standards. And okay, so if I want to reach this frame size, what my camera lens should be there, or what is the shutter speed I need to get for the video. Those are the things it is represented in here, in down. So the shutter speed, in the sense, whenever we take a camera, whenever we capture a photo or video, the lens will have a shutter, it will open and close. So it's kind of a sampling. So it will not take a continuous video or image, means it will not capture like this. So the lens, different scenes are captured. This different scenes, that's what we'll say frames per second. So video, in the sense, it's a multiple images stored in a second. So how much time this lens closing and opening will happen, that's what the shutter speed. Okay, so to take one image, my shutter has to close and open once. So if I want to take two images, 2 times it has to close and open. 2 times the sampling should happen. Okay, so the down, it's mentioning, the frame rate, it's mentioned by 1/2 into the shutter speed. So it's half of the thing. So 60 times, if I'm opening and closing the shutter, in the sense, 30 frames I can able to take. That is the only thing. So this is a different scenarios. What about the different scenarios for the frames per second? So in case if I am capturing a video for the freezing or fast moving cars, so what should be the minimum frames per second, or what should be the shutter speed to capture as a smooth video? Okay, in case if it is a fast moving car, if my shutter speed is 1/1000, it means 500 frames per second, then only I can able to capture the car properly. Otherwise a blurred image will be there. Normally any camera, when you capture a fast moving thing, whenever it's moving very fast, it will be blurred. We can't able to see whether it is a car or bike or something else. Okay, so it should have minimum of 500 frames per second to get the proper information inside the video. So similarly for the adult running, it will be 125 to 250 frames. It's not 25 frames. So if it is 25 frames, if you are keeping, whenever we move, there's something like when you take a picture in your mobile, if I move a hand alone will get blurred. I'll be proper. Okay, so that is the reason. So whenever a moving object is there, what should be the minimum frames per second or the shutter speed to capture the proper information? So adult walking, in the sense, it's 60 to 125 frames. So normally any cameras will use this 60 to 125. Normal running or normal walking or normal movement, anything is there, the 60 to 125 frames per second is sufficient to capture the proper information. That's what even still 60 megapixel camera or 100 megapixel or 40 megapixel camera in our mobile still can't able to capture the proper scene whenever we move. Many times we'll take a picture, we'll say it's shaked. So it's not shaked, the shutter speed of the camera is very less. It can't able to capture the proper information. So for the scene, with respect to the scene, we need to define the shutter speed. So the shutter speed will define your quality of the information in the video. So the slow motion cameras, they'll say 8000 frames per second, 10,000 frames per second. So those many frames means those many different images it can able to take within a fraction of a second. So till now we've seen what are the size of the image and what is the pixel size, everything. But per second, if I'm capturing one frame, in the sense, it's sufficient to process one frame within a second. But if I process 30 frames, if I generate 60 frames per second, I need to process 60 frames. So if it is a VGA standard, 480 x 640 per frame, that means 1 frame per second, in the sense, this is a million bits per second, 2.45 million bits per second is there for the VGA standard. So I need to process 2.4576 bits in a second. For a VGA standard of 8-bit resolution alone, per second, I need to process these many bits. So if it is 30 seconds, it's 73 million bits per second. If it is 60, it's 147 million bits per second. So similarly, if from VGA, if I keep on move to the next standard, just look on the bits. So per second, if I want to process these many bits, so what should be my system speed? So how much effective my system should be? So how the output will be? Till now, whatever we discussed, it's everything about the inputs. So how the input is there, what it has, and what is the information it has, what is the levels of information, and what are the number of bit size for the information. But once I process, whether I need to preserve this for the output. Suppose I'm not going to store the video, I'm just displaying it. Sometime we'll not store the video, we'll just use a cam to just direct display of some TV monitors. Okay. During that times, I don't need to store for the high, I don't need to preserve the bit size, or I don't need to preserve the much quality inside it. So whatever the screen size is there, whatever the resolution for the screen size, there, if a smooth variation of pixels are there, that is sufficient for us. So during that time, I can still compromise myself for the processing system. In case if it is captured and stored for some other purpose, in future I need to check it. So for what purpose I am going to store it, I need to check it. So based on that, how much I can able to preserve the information I can fix. So still you can able to see two images. One will be a larger one, another one will be a smaller one. These two images are one and the same. It's nothing. This is a proper image. I just drag the picture, zoomed it. So whenever I zoom it, we'll get a blurring of this, a picture with the blurred image, but still as a flash, we can able to understand this is a kid picture. Okay, and what may be the face, what may be the similar kind of features the face has. Okay, still without this image, still we can able to understand this is a baby, and this baby has something like this face. Okay, so our brain can easily understand this, even for this. But if it is a system, how it will understand? So whenever I process, I should have the proper data. Normally, whenever we are processing an image or video, mostly we'll try to extract the features, something like edges or something like a shapes. So if this shape is there, I'll go for this. Okay, this is maybe a dog, this is maybe a human, this is maybe a car, this is maybe a cycle, something like that. So if edges are there, definitely a sharp variation is there between the two varieties. That means two different objects may be there, I can able to understand. But if the picture is like this, machine can't understand properly. So if the machine want to understand, then how the machine reading the data, we need to understand. So normally in the olden CRT tubes, or initially whenever we speak about the video or image which is displayed in the machines, we'll know that horizontal and vertical. Initially the pixel will start here, it will move for the horizontal, and again it will trace back, again it will move back, again it will trace back, something like this. It will keep on move with the horizontal. So this horizontal syncing and vertical syncing is most important one. It's something like one tip point is there, it will keep on read the values of the pixel horizontally. So once it reaches the end point, again it has to come back to the starting position. So initially when I read for the first line, from the first pixel to second pixel, the timing is different. So once I reach the end point, I need some more time to get back to the initial position. Then again, I need to move. Something like this, I have to keep on moving till last pixel. So this is for the first frame. Once I move to the last pixel position here, my tip has to move to the 0th location. So here, my timing is different. So this timing defines how your picture will be. In case, for keeping this pixel in horizontal or moving back to the original position, whatever the timing is there, if it is not proper, then we will not get the proper video. Whatever we capture, it will not be proper. It will be something else. So this we will call as the horizontal and vertical sync line. It's something like you can able to see from here to here, this is the picture time or active area. So within this time only, I can able to read the proper pixel values. So what about the remaining? These remaining things will used for the system to reset it back to the initial values. Because whenever I start, I process, I'll go somewhere, I don't know where to start again. So it has to come back to the initial state, then again it will do the same thing back. So once it reached here, we can able to see front porch and back porch. These are the dummy pixels. So initially, whenever horizontal sync starts, I'll say I'm going to start my horizontal pixel positions. So whenever I say horizontal pixel position is started, on a sudden I can't read the pixel values. So my system has to reset the registers with the proper values. I have to start. So it need a minimal area for the back porch. So this back porch is a dummy pixels. These are not the valid pixels which is generated by the camera. Okay, these are the pixels for the output devices. Okay, a dummy pixel. So within this time, the tip will come back to the original position. So horizontal position is started. So you can come back to the original position. To say that we need this time. So once it reach the back porch position, it will start reading the pixels. Okay, so this is the reference point. So once the horizontal pulse reference point reached, so initially it will count the number of pixels for some duration for the back porch. So once the back porch ends, it will start reading for the VGA pixels or the frame pixels, whatever we have. So from that I know what is the resolution for my image, 640, 320, anything. So I'll count 640 or 320. Once it finished, again it has to set back to the last final pixel. So nothing else is there to read more, to say that some other smaller area is required.